the other sections, I haven't discussed this yet sa ilaha. Okay, before I proceed on the last topic on pharmacodynamics principle. Okay, so let's start. Now, in studying drug receptor interaction, it is important that you understand also the features or the characteristics of a ligand, different ligands upon interacting to a receptor. And there are two most likely observed characteristics of a ligand. One is affinity, then the other one is intrinsic activity. When we say affinity, of course, any ligand must have this property or feature, and this tells the ability of the ligand to bind to a receptor. Its ability to bind to the active site of the receptor. Ligand, as long as it is present in the receptor targeting substance, may it be endogenous or exogenous na ligand, it must have this, it must exhibit this feature. It should bind actively to the site of the receptor, active site of the receptor. And then the second feature observed in ligands is the intrinsic activity. This one, it tells the ability of the intrinsic activity is only observed for those ligands with the ability to stimulate or activate the receptor, and then eventually leading to a cellular response. Now, since not all ligands are able to activate receptor, there are also ligands that could block or inhibit receptors. That resulted to two general classification of ligands. That is why we have agonists, classified as agonists, and we also have those that inhibits or blocks receptor, the antagonist. So later, next slide, I will discuss about antagonists. So let's start with the first classification of ligands. We have agonists. Agonists, these are synonymous to the term activators. They are also classified as activators or stimulators. Okay? So being an activator, they should exhibit the feature intrinsic activity. They should have that ability to activate. At the same time, the affinity. Okay, so it has both the affinity and the intrinsic activity. Now, there are three different types of agonist, and they only differ to this degree to activate a receptor. So they only differ on intrinsic activity. I repeat, all these three, same yung degree nila when it comes to affinity. They have the same degree of affinity, same degree to bind the active site of the receptor. They only differ to their ability to activate a receptor. Okay, and for you to easily differentiate their extent or level, their degree to activate a receptor, we usually make use of the quantile unit for intrinsic activity. Let's say 0 to 1. Yung 1 would be the maximal effect. Maximal effect. This is to easily differentiate the differences in the extent or degree of their intrinsic activity. 0 to 1, 1 being the highest, kumbaga, or the maximal effect. So when we say full agonist, yung magiging intrinsic activity niya would be full, so maximum effect is being achieved. So ito yung intrinsic activity niya, 1, effect is maximal. Meaning the full pharmacological response is produced as long as there is occupancy of the ligand to the receptor. Then kapag naman partial agonist, so it's in between 0 and 1. Okay, kaya nakalagay dyan, intrinsic activity is above 0 but less than 1. above 0, less than 1. So it's not 0, it's not 1, it's between 0 and 1 yung magiging intrinsic activity niya. That's why it says here, it produces some only, some of the expected effects. Okay? And take note, it has a mixed agonist and antagonistic effect. Okay, another important thing that you have to take note about partial agonist is that they should never be combined with a full agonist. Never combine a partial agonist with a full agonist, because ang tendency, the partial agonist will compete with a full agonist to that receptor. It will compete and it will act as antagonist. So kumbaga mag-act siya as competitive inhibitor. It would act as competitive inhibitor. Let's say for example, morphine. Morphine is a known full agonist. Particularly, it activates the receptor mu opioid receptor. So yan yung pangalan ng receptor kung saan nagbabind yung morphine producing or eliciting an effect. Okay, so again, yung tawag is mu. So ganito siya pagkasulat. Mu, opioid. Opioid receptor. Okay? So, isa siyang full mu opioid receptor agonist. Okay? So, ang expected effect niya, syempre kung ano yung dala-dala na kumbaga response ni morphine towards that receptor, and that is analgesia. Okay, analgesia. So, upon activating that mu opioid receptor, it should produce, expected talaga na it would produce analgesic effect, being a full mu opioid agonist. Okay, pero in the presence, if it is added with a partial agonist, in the presence of a partial mu agonist, tendency, the partial agonist nalbuphine, for instance, will compete, it will overpower with morphine in the mu receptor. In the mu receptor, in this receptor, so makikipagkompetensya si nalbuphine, it will act as competitive inhibitor, causing antagonistic effect. Kaya, as a result, that would decrease the analgesia effect. So it would counteract the full pharmacological response ng morphine if it is being added with a partial agonist. So in nature, that's the action ng partial agonist if it is combined with a full agonist. Kasi nga meron siyang mixed agonist and antagonistic effect. And then lastly, the inverse agonist. Yung intrinsic activity naman niya is below 0. As in less than 0. Okay, nakalagay dyan, less than 0. Or it tells us na negative yung intrinsic activity niya. Negative. But it doesn't mean na kapag negative intrinsic activity, it's 0 at all. Wala talagang intrinsic activity. Diba sa kung sa graph, di ba may negative part yung graph. So, negative values is not equivalent to 0. Okay, so may positive and may negative. So yung inverse agonist, yung activity niya sa receptor would be negative intrinsic activity. Bali, ang nangyayari, it will still bind to the active site of the receptor where the agonist binds into. I repeat, the inverse agonist will also bind to that receptor, same with the agonist. But the pharmacological response will be opposite now with the agonist. Opposite in a way na yung gagawin ni inverse agonist, it will decrease or prevent, it will decrease or prevent the constitutive or basal receptor activity. So sulat ko ha, again, it will decrease or prevent the basal or the constitutive receptor activity. Okay? So yung requirement dito para pwede gamitin ang isang inverse agonist is dapat in nature or naturally ang isang receptor meron na siyang basal receptor activity or constitutive activity. Meaning ana, kahit walang agonist na mag-bind sa kanya, it already carries somehow a constitutive receptor activity. Meron na siyang activity na ini-exhibit kahit walang mag-bind sa kanya na ligand. Yan yung requirement para gumana yung inverse agonist, of course. Okay, halimbawa, yung GABA receptor, yung GABA A receptor, example, GABA A, the subtype A receptor. This is an example of a receptor that already exhibits a constitutive property ng receptor or constitutive activity ng receptor na kahit walang mag-bind sa kanya na GABA, gamma aminobutyric acid na neurotransmitter, an endogenous substance, naga-carry na siya og basal lang nga activity. Of course, kapag basal activity, it's not equivalent to the activity being elicited kapag may agonist na nag-bind sa kanya. Basal lang, no? Basal constitutive activity. Meron siya. Okay? Now, in cases na nagiging hyperactive yung isang receptor, hyperactive siya na kumbaga nagiging hypersensitive ang receptor or overactive masyado yung receptor na kahit walang nag-bind sa kanya na agonist, nag-elicit na siya ng activity and that could be harmful, then that's the time you can use that inverse agonist. So meron tayong mga inverse agonist na yung ginagawa, it will just decrease or prevent the basal receptor activity. So negative intrinsic activity yung ginagawa niya sa receptor. Okay, so it's not zero intrinsic activity. Dinidecrease niya lang talaga yung basal receptor activity. Okay, so it's not zero intrinsic activity. Kasi kapag zero na, antagonist na yon. Magkaiba yun sa inverse agonist. So I hope you understand na iba si inverse agonist sa antagonist. Okay, so let me introduce what is an antagonist. Kapag antagonist, talagang zero yung intrinsic activity niya, zero at all. Meaning to say, it would really, upon binding to the receptor, it would disrupt the interaction anymore of the other ligands like the agonist or the inverse agonist. Hindi nakakabit doon. Okay? So na-inhibit talaga yung intrinsic activity of the not the intrinsic activity, the response of that receptor or the receptor activity. Okay, kasi zero na yung intrinsic activity. Wala siyang kinikerry na ganon si antagonist. Okay? So, wala talaga siyang ability to activate. May it be increasing the response, the effect of that receptor, or lessening or preventing or decreasing the receptor's activity or the basal receptor activity. So, meron lang sa kanya affinity. Okay, that's the property of agonist. Sulat ko no receptor activity at all. No receptor activity at all kapag nag-bind si antagonist sa receptor. No more receptor activity. No basal constitutive receptor activity. So, di ba magkaiba talaga siya kay inverse. Kasi again, si inverse, may receptor activity, decrease lang. Decrease yung receptor activity. Now, there are different ways how antagonism is observed or being produced by a drug. Again, yung antagonism property ng mga ligands could be in different ways. Example, pwedeng based on mechanism of action, pwede ding based on type of interaction, pwede din based on surmountability of interaction. So we will discuss that each. So let's mechanism of action. Sorry. Ayan. So under mechanism of action, pwede yung antagonism is via functional one, Pwede din receptor or chemical antagonism. Let's start with functional. Ang functional antagonism, this is also known as physiologic antagonism, meaning you have two separate drugs, two different drugs that binds to different receptors. So let me illustrate that. Example, you have ligand A, label ko. Then you have another ligand B. So separate drugs, separate ligands, magkaiba sila. And at the same time, nagbabind sila on a different receptor. Let's say ang receptor, you have a receptor X, then dito receptor Y. And then yung nangyayari, upon binding these drugs to their specific receptors, their activities, their functions are antagonistic with each other or opposing with each other, antagonistic. Okay? So meaning ang isang gamot, ang function ng isang drug, it opposes the function or activity of another substance, though they bind on different receptors. Example, let's have, for instance, ligand A is epinephrine. Kasi yun yung nakasulat dito, no? Epinephrine. So, halimbawa, epinephrine yung ligand A. And please take note that the ligand A epinephrine here, epinephrine, it binds to variety of adrenergic receptors. Maraming adrenergic receptors na pwede siyang mag-bind. So it has affinity with beta 2, for instance, beta 2 receptor. Meron din siyang affinity to beta 1. Also, it has affinity to alpha 1 receptor. Okay? Now, let's extract, for instance, yung one of the receptor kung saan siya nagbabind actively. Epinephrine could activate beta 2 receptor in the bronchioles. There are beta 2 receptor distributed in the bronchioles, and if the beta 2 receptor in the bronchial smooth muscles are activated by epinephrine, result is bronchodilation. So that's for epinephrine's effect upon binding, activating beta 2 receptor. Okay, so again ha, yung epinephrine dito acts as beta 2 agonist. Okay, next. Let's have another drug naman. Separate drug. Example, yung ligand B is histamine. Sabi dito, histamine naman yung ligand B. Sulat ko, histamine. So histamine would bind, of course, to the histamine receptor. Pwedeng histamine 1, histamine 2 receptor. Or let's extract one. Halimbawa, yung Y dyan, receptor Y, specify natin na halimbawa yan ay receptor histamine 1 found in the bronchioles. Kasi meron ding mga histamine 1, that's bronchioles ha, may mga histamine 1 receptor din found in the extravascular smooth muscle. So example, sa bronchial smooth muscle. Now, kapag nag-bind yung histamine sa histamine 1 receptors in the bronchial smooth muscle, this time, the effect is bronchoconstriction. Bronchoconstriction. Okay, so if you observe, diba, the response of both substances are antagonistic to each other. So this is an example of a functional antagonism because the function of one drug opposes another drug's function or activity. So opposing yung isa dilation, yung isa constriction, and yun yung concept ng functional antagonism. Dalawang gamot, they bind to different drugs, antagonistic with each other, yung physiologic effect nila or yung functions nila. Okay, let's proceed. Receptor antagonism naman, this is also known as pharmacologic antagonism. Okay, so this time, ganun pa rin, dalawang gamot, dalawang substances, and when they are about to bind on the receptor, same receptor sila, nagbabind this time. Okay? And then, upon binding to that same receptor, antagonistic yung response nila. So most probably yung isa dyan is an activator of that receptor. The other one is a blocker of that receptor. Kasi nga, on the same receptor man sila nagbabind. Okay, so yung magiging realization nyo, bakit antagonistic to each other sila kapag nagbind on the same receptor? Probably yung isang gamot, activator, yung isang gamot naman is a blocker. Kaya antagonistic talaga with each other ang effect. Okay? Sige. So, ang sige, bigyan ko kayo ng idea. For instance, epinephrine. Epinephrine ulit, and it has, dito ko na lang ilagay. Yung epinephrine, di ba sabi ko kanina, meron din siyang affinity sa beta-1. Ayan, beta-1 receptor. Halimbawa, it binds to beta-1 receptor found in the heart. Kasi merong mga beta-1 receptor found in the heart. Do not worry ha, yung mga receptors na yan, madadiscuss natin yan sa ANS nga pharmacology. For now, just know the concept on antagonism. Nagbigay lang ako ng halimbawa. Bakit antagonism sila na with each other? Okay, so I repeat, epinephrine is said to be a beta-1 agonist, a beta-1 receptor agonist. It would activate the beta-1 receptor, example, found in the heart. And yung effect would be tachycardia. Okay? Yung effect niya, activating the beta-1 receptor in the heart, that would cause tachycardia or increase yung heart rate. Okay? Increase heart rate. Okay? And then kapag naman histamine, sulat ko beta blocker, sorry. Beta blocker pala. I overlooked dito pala. Beta blocker yung isa, beta blocker. Ayan, so you know already what's the identification by name, no? Kung beta blocker ba yan, those ending in olol. Ayan, ending in olol. So, obvious naman kung ano yung activity nila, they block beta receptor. Kaya tawag sa kanila beta blocker. So, upon binding to beta-1 receptor, for instance, it would block the beta-1 receptor. Kaya ano yung opposite ng tachycardia? That would be bradycardia. Okay? So again, observe na antagonism with each other yung effects nila, yung pharmacological responses nila upon binding to the same receptor. So yan naman yung concept ng receptor antagonism, or that is pharmacologic antagonism. One drug is an activator of that receptor, the other one is a blocker of that receptor. Okay? Sige. And then the third type of antagonism based on mechanism of action is the chemical antagonism. This is also known as inactivation process. So kapag inactivation, you have one drug that will inactivate the other. That's why antagonism. Diba? May antagonism na nangyari or opposing ng pharmacological responses. Okay, so purely chemical reaction ito. Halimbawa, yung mga na discuss natin ng mga example under chemical, direct chemical interaction, di ba? Yung protamine. Halimbawa, it is a known antidote of heparin, di ba? Isa itong antidote sa heparin toxicity. Antidote. So to inactivate heparin's action, we can make use of protamine. And what happens here, di ba? Purely chemical reaction. What chemical reaction ulit yun? Neutralization, di ba yun? Kapag protamine, heparin. Amine as the base, heparin with an acidic property. Then another example is yung deferoxamine. I hope you can still remember deferoxamine, the antidote naman of iron poisoning. Okay, iron poisoning. Okay. So ayan. So ang si deferoxamine, ganun din yung ginagawa niya, inactivation of iron metal. How? Via chelation. So that via reaction. Okay, very good. Via chelation. So it's a chemical reaction. It's chemical antagonism. So under siya sa chemical antagonism. Kapag functional receptor antagonism, it has something to do with receptor, binding to the receptor. Kapag different receptor sila nagbind, functional. Kapag same receptor sila nagbind, then that's receptor antagonism. Okay? Sige. And then, let's proceed to the second general type of antagonism based on type of interaction. So there are two. Pwedeng reversible ang interaction, pwede din naman irreversible ang interaction. Kapag reversible, madali lang naman maintindihan, no? Kapag reversible, yung antagonist's activity towards the receptor is only temporary. So pwedeng ma-reverse back. Okay, temporary. What happens here is the bond that connects the antagonist and the receptor is a weak type of bond. Kaya pwedeng ma-reverse yung interaction. So again, itong bond na ito, highlighted with color red. Ayan, as that antagonist, then you have a receptor. Yung bond na yan is a weak type of bond, weak force of attraction. And in pharmacology, kapag drug ligand to receptor interaction, and then force of attraction, yung pinag-uusapan, weak force of attraction considered are those non-covalent bonds. Non-covalent bonds. Or included din dito yung mga weak forces of attraction, yung van der Waals, and also yung hydrogen bonding. These are weak type of interaction between a ligand toward a receptor. So kapag, of course, weak yung force of attraction that connects the two entity, then pwede talagang madali siyang ma-break, then temporary lang yung interaction, reversible yung interaction. Kaya less than, yung duration of interaction would be lesser. Kaya less than 24 hours, for instance. Then irreversible interaction naman kapag longer this time yung duration ng interaction of the antagonist to the receptor. Okay? And the reason is, opposite naman ito, strong bond naman yung nagko-connecta sa antagonist at saka receptor. Okay? Kaya irreversible yung interaction. So you have antagonist, then ito receptor. Itong bond na ito is, let's say, a covalent type of bond. Covalent bond. Okay, so meaning to say, irreversible interaction if the antagonist is covalently bonded to the receptor. Kapag covalent bond yung nagko-connect, then somehow longer yung interaction nila with each other. Kaya pwede nating masabing permanent yung effect. Permanent effect. Okay? Pero hindi siya permanent na forever ha. Syempre, di ba, ma-excrete man yun na ang gamot. Permanent effect as long as bounded dira si antagonist sa receptor. Okay? So it will last more than 24 hours. So that's the concept under type of interaction. Pwede reversible or irreversible. It tells about the type of force of attraction that connects the antagonist and receptor. Antagonist and the receptor. Okay, then lastly, we have based on surmountability of interaction. Okay, so we have two also under this, the competitive antagonism or the surmountable and the non-competitive antagonism. It's also easy to understand this concept. Kapag competitive antagonism, meaning surmountable yung effect ni antagonist. Pwede nating ma-overcome, let me erase first. Pwede nating ma-overcome yung effect ng antagonist by simply increasing the dose of the agonist. Let's say this is the receptor And then the antagonist that tends to bind to the receptor, eliciting an effect, can be overcome, can be surmounted. How? By simply increasing the dose of the agonist. Okay, so we have this type of antagonism. So kapag ganito yung nangyari, kapag in-increase yung dose ng agonist tapos na overcome natin yung antagonistic effect nito, then competitive type of antagonism yun. But in cases na kung saan kahit anong increase pa ng dose ng agonist, talagang hindi na ma-overcome yung effect ng antagonist, then that's the time non-competitive yung antagonism. Okay? So kahit anong effort nyo pang i-increase si dose ng agonist, hindi talaga niya ma-overcome yung effect ng agonist. What happens here is, for instance, this is the receptor. And then, yung portion na ito, yung nasa taas, let's say that is the active site. The active site of the receptor. And then we have here, halimbawa, the antagonist. Non-competitive antagonist if the antagonist involved here is an allosteric type of antagonist. When you say allosteric antagonist, this time, excuse me, this time the allosteric antagonist would bind to the allosteric site. Okay, allosteric site of the receptor. So ito naman, kung yung nasa taas labeled is the active site of the receptor, ito naman allosteric site of the receptor na kung saan doon magbabind ang isang allosteric antagonist. Okay? Kapag yung antagonist na yan is termed or classified as allosteric antagonist, talagang magbabind siya in nature doon sa allosteric site ng receptor. Now, in cases na doon siya nag-bind, ang mangyayari, gagawin ng isang allosteric antagonist, it will cause change in the conformation of the active site of the receptor. So, kumbaga, from that sani, kanang structure, kumbaga, ng active site or fitting na stereo conformation ng active site, machi-change siya. Diba? So magkaiba yung initial, then yung pag-bind na ng allosteric, this is the allosteric antagonist. Pag-bind na ni allosteric antagonist, na iba na yung stereo conformation ni active site. Kaya kahit anong increase pa ng dose of the agonist, talagang hindi natin ma-overcome completely yung effect ni antagonist kasi naiba na yung conformation ng active site. Eh, di ba parehas lang naman talaga yung kumbaga particular structure ng isang antagonist and the agonist. Example, kung ito yung tatargetin nila na receptor, dapat fitting on that conformation, yung shape na dyan ng active site. Ganon din yung shape ng isang agonist at antagonist that tends to bind on that specific receptor. Diba? Initially, parang box man yun. No? Parang box man yan dyan. Yung ma-fit dyan sa initial na conformation ng active site. So yun dapat yung shape din ng isang agonist. So kahit i-increase mo pa yung agonist na dose of the agonist, talagang hindi na yan niya ma-overcome yung effect ng antagonist. Being an allosteric antagonist, yung nag-bind doon sa receptor. Magkakaroon ng conformational change sa receptor. Okay, so that's the difference between competitive antagonism and non-competitive antagonism. So again, competitive, if upon increasing the dose of agonist, we can overcome the effect of the antagonist. Non-competitive naman kapag cannot completely overcome the effect of antagonist even by increasing the dose of the agonist. Okay, so those are the different types of antagonism. So we have based on mechanism of action, interaction, and based on the surmountability. Okay, then we'll proceed to the last subtopic under pharmacodynamics. Then next week would be pharmacokinetics principle. Sige, so tatapusin natin ngayon ha yung pharmacodynamics principle. And yung last topic is all about dose-response relationship. Okay. Now, in dose-response relationship, we try to understand here the relationship of the response. Ayan. So effect or the response of a drug and the dose of the drug. Okay? So yung relasyon ng effect towards the dose of the drug or the concentration of the drug. Also, you will learn here how we can graphically represent this kind of relationship. Okay? And usually, yung graphical representation is also known as dose response curve. So later, I will introduce a kumbaga, graphical representation of the dose response relationship. Okay, so by definition, dose response relationship again, it is a systemic description of the magnitude of the effect, the extent of the effect of the drug as a function of a dose. So if you try to highlight the keywords, it's really the relationship of the magnitude of the response, magnitude of the effect as a function of its dose. Okay? So let's say, for example, um, you've heard about CCBs, di ba? I've mentioned about CCBs, the calcium channel blockers. Now, in general, ang mga calcium channel blockers, they are classified as antihypertensives. Okay, I repeat, they are classified as antihypertensive agents, meaning to say they can lower blood pressure. Again, they can lower blood pressure. Of course, its effect to lower blood pressure, it is being accompanied by a certain dose, a certain concentration of a drug. Let's say, for instance, in the market, there are available calcium channel blockers like, let's say, amlodipine, diba? Ending in dipine, diba? Those are CCBs. So mag-specify ako halimbawa ha, amlodipine. Okay? So ang amlodipine in the market, merong mga available concentration na or dosage na 5 milligrams of amlodipine. So of course, at that dosage, it can elicit already this activity, lowering blood pressure, being an antihypertensive drug. Okay? So there really has an existing relationship no between the dose and its response particularly to lower or to reduce the elevated blood pressure. So we can realize here na if there is an increase, let's say, kasi di ba may relationship daw yung concentration tsaka yung effect niya. So paano kapag in-increase natin yung dose no ng 5, for example, from 5 milligram, in-increase yung dose to 10 milligram. Since may relationship yung dose at saka effect, we could tell then na meron ding definite increase sa kanyang response if we increase the dose. If generally speaking, di ba? Kasi may relationship nga yung dose at saka response. Okay? So we could say again in general na there's an existing relationship between dose and then effect. The more the dose, the more the concentration of a drug, then the more response is achieved. Okay? Ayan. So yan yung concept ng dose-response relationship. Okay? But of course, there are certain cases also na upon increasing the dose, it will bring about some adverse effects. Okay? Or Naapoy uban nga increasing the dose, maybe the effect of the drug is not achieved at all. Okay? Pero ito, general ito. Generally speaking, hindi ko naman sinabing lahat talaga, yung most lang, mostly, yung general concept when it comes to dose at saka response, directly proportional talaga yan. No? So, the dose of the drug will really be directly proportional to the kind of its therapeutic response na kayang i-achieve. Okay? Sige. So, I repeat, sabi ko kanina, yung relationship ng dalawang variable, it can be easily illustrated through a dose-response curve or graph. Okay? And in the curve, halimbawa, this is the graph representation for the dose-response relationship. In this curve, the x-axis will plot the dose. Kaya may nakalagay dyan, no, sa x-axis, dose of the drug. Or nakalagay dyan log dose kasi the dose of the drug in this concept is usually expressed in a logarithm scale, in a logarithmic scale. Okay, kaya ang tawag din sa kanya is log dose. But ang point dito is it tells us na that is about the concentration of the drug, the dose of the drug. Okay? Concentration of the drug. Now, on the y-axis naman, it plots the response. Or this is also the measured effect, the measured effect of the drug. Okay? Or that tells us the efficacy of the drug, the response, measured effect, efficacy. And then yung nakikita nyong line dyan, itong highlighted with color blue, that is already the dose response curve. That is the dose response curve. Okay? And that should be plotted. Its importance is para madali nating maintindihan, ma-identify yung mga parameters involved in the dose-response relationship. Okay? So generally, upon plotting the concentration of the drug or what we call the log dose, the logarithm of concentration ng gamot, that usually results to a sigmoidal type of graph or sigmoidal plot. Okay, so yung halimbawa na to is a sigmoidal graph, sigmoidal plot. Okay? And then the other type of graph also na pwedeng ma-observe upon plotting the logarithm of the concentration ng gamot against its effect, okay, is the hyperbolic. Yan, the hyperbolic na curve. And that is shown in a dashed line. Ayan. Now, between the two, between sigmoidal and hyperbolic, more conveniently used is the sigmoidal graph. This is for the reason na, again, madali lang natin ma-identify yung mga parameters, mga sub-variable involved in the dose-response curve using sigmoidal graph. Okay? So yung mga parameters mamaya, I will be mentioning that later on when we discussed each of the examples ng dose-response curve. So basically, there are two types, primary types of dose-response curve. One is the graded dose-response curve. And then the other one is the quantal dose response curve. Okay? So ito yung dalawa na i-discuss natin na dose-response relationship, the graded and the quantal. Oh, let's begin with the graded dose-response. Ayan, next slide. Okay. Talking about graded dose-response relationship, based on the term itself, diba sabi, graded dose of graded meaning we are increasing here. Graded, di ba? Kung mag-grado kay ay grade mag-level up man na siya, grade gradually. No, increasing gradually in proportion. So parang ganun. Okay, so sa graded dose response relationship, it only describes that the drug's effect will gradually increase. It will gradually increase upon increasing the drug's dose. Kaya graded dose response. If we gradually increase the dose, ganun din yung mangyayari sa response. Okay? So yan yung mangyayari mamaya. Okay? And usually kapag graded response ng drug, this is observed or seen in a single individual. Meaning is person to a person, individual lang siya, dili siya by set of population. Basta graded dose response gid nga relationship, observed siya and kanang ginagamit ni siya if ga-observe kag relationship sa effect and the dose to a certain person, isang individual. Okay? O individual, ana. Okay? So between the two graded at saka quantal, between these two type, ang graded dose response yung very commonly used. Okay? In pharmacology, na usually ginagamit lang yung isa, yung quantal, if kanang dinaghan na, example population na ang ginaobserbahan for their effect, kung unsa ilang effect on or unsa ilahang outcome upon receiving that drug. So tinitingnan, ino-observe ng pangmalakihan by population basis, then that's the time quantal dose response relationship yung gagamitin. Pero pagkapag ito, individual siya, individual. Okay? So I hope you understand that. Then prior to discussing this, itong graded dose response, siyempre you have to understand first the parameters para maintindihan nyo yung applications ng paano siya ginagamit ba? Bakit siya ginagamit? Paano siya gamitin? You have to understand the terms or mga parameters that are being involved in the graded dose response. Okay? Sige. So one of the parameter involved in this type of curve or in this type of relationship is the efficacy. Ayan. So efficacy naman, this is also known as ceiling effect. It is known as ceiling effect, or it tells us about the maximum achievable response. Maximum achievable response ng isang gamot. Okay? Maximum achievable response of a drug. Let's say for example, in this given curve na binigay on the right, yung efficacy would be this. Diba sabi ko kanina yung y-axis is the response. So it tells about the efficacy. Okay, so kung maximum achievable response of a drug, then ito yung magiging efficacy niya. Ito yun. Okay? Itong part na to. Yan yung maximum effect niya. Okay? So at this kumbaga at this point, no? At this point sa y-axis, yan yung efficacy. Okay? Kasi yan yung maximum response na na-achieve ng isang gamot. Okay? Base dito na graph, kung base dito na graph na in-illustrate. Okay? So yan yung peak niya na achieve for its response. So that's a ceiling effect. Ceiling dose naman, ceiling dose means from the word dose, so it has something to do with the dose. Particularly, it's the smallest dose that produces the maximum response. That produces the maximum response. So I repeat, kapag ceiling dose of a drug, that's the smallest dose that produces the maximum response. So no problem with the maximum response. Yan yung efficacy, di ba? Nakuha mo na yung efficacy. So kapag dose, you have to plot it down kasi yung dose nasa x-axis man yung dose. Labeled ko ulit yung dose, diba? Ito yung dose. So if this is the efficacy maximum response, you plot it down from here. Hindi yata, parang dito. No, dito yung maximum response. And we're talking about the smallest dose. So yung pinakamalapit sa zero. Yung pinakamalapit sa zero. Okay? So you plot it down. Ito yung magiging ceiling dose ng gamot. Okay? Again, highlight ko ha. If ito yung efficacy, ito, yung kulay purple na in-encircle. Kung yan yung maximum na-achieve na response ng isang gamot, kapag dose naman, dapat ito yung baseline mo, si x-axis. Okay, so from its maximum response, you plot it down, then that's the ceiling dose, smallest dose that produces the maximum response. Okay, and then kapag potency naman, potency that is the dose as well. Kapag potency, it also tells about the dose. But this time, the dose that is required to achieve 50% of the maximum response. Okay, so to achieve 50% of the maximum response. Excuse me. Okay, take note. Always take note na kapag potency, the lower the dose of the drug or the lower the value of the dose. We could say na more potent ang isang gamot. I repeat, the lower the value of the dose of the dose, the more potent is the drug. The more potent is the drug. Okay? Paano natin masasabi na lower dose? Kapag malapit sa zero. Diba? Kapag malapit siya sa zero, then it already attains 50% of the maximum response, then that's a more potent drug. Okay, so sa graph, kung kukunin naman natin yung potency, sabi dito 50% man, 50% muna. Yan yung dose na na-achieve. Yan yung dose na kailangan to achieve the 50% of the maximum response. So dito muna tayo, 'di ba ang efficacy, yan yung maximum response. So no problem. Let's say 100 yan. So natin yung maximum response. Ang 50, kunin mo yung 50%. So yan, ito naman yung 50%. 50% ng efficacy. Then you start plotting, then ito, yan yung 50%, then plot it down. Plot it down. So ito yung magiging potency of that drug. Okay? Kasi yan daw yung dose. So ito yung dose, nasa x-axis. Yan daw yung dose na kailangan to achieve 50% ng maximum response of that drug. Okay? So for this drug, ito man daw yung curve niya. Then, ito yung efficacy niya, maximum na na-attain na response. 50% of that. And with this dose, na-attain niya yung half of the maximal response. Yan yung potency. Okay? So I hope you understand. Sige, balikan natin. Efficacy, yan yung maximum na na-achieve na response ng gamot. Ceiling dose, yan yung dose that smallest ha, do not forget, that's the smallest dose na produces already the maximum response. So ito yon. Potency naman also tells about the dose, but the dose that is required to achieve at least 50% of the maximum response. Okay? Now later, when you are asked to identify which among the drug is more potent, take note of this. More potent ang isang drug if it has the lower value of the dose. Lower value of the dose if it is malapit sa 0. Okay? Now, I will also introduce another parameter, although it is not applicable, pero it will help you understand the relationship as well of the concentration and the response relationship, or the the dose and then the response relationship. For a while, let me take my personal necessity for a while. Okay, sige, let's resume. Okay, we have the fourth parameter, which is the slope. Okay, sulat ko. Dito na, okay, dito ko na lang isulat. For a while. Ayan, so number 4, slope. Yung slope naman, this is the degree of change. It only tells about the degree of change in response, degree of change in response with a change in a dose, with a change in dose. I repeat, yung slope, it tells us the degree of change in response with a change in dose. Okay, so kumbaga, it only describes the steepness of the curve. Okay, the steepness of the plot, or the steepness of the plotted graph. Okay, kasi it will affect how drastic is the change in the response upon changing a dose. Let's say, for example, let me illustrate 2 graph. And then the curve for the first graph looks like this. Halimbawa lang. And then the other graph, okay, let's say, parang ganito. Again yung y-axis, that's the response. And then the x-axis, that's the dose or the log dose. Ayan. And then the response. So 2 different dose response curve. No, different yung dose response curve na present in illustrate. And let's say if we try to check if naabay difference on the upon adjusting the dose given, naaba siya drastic change pud ba sa iyahang response, pwede na siya ma-check with this 2 graph. Example, diri nga concentration 1 milligram, then dere 2 milligram, ganun din sa PCAS, then 1 milligram, the other one 2 milligram. Okay. Now at this point, you can tell nga kani siya at 1 milligram, tingnan ha, at 1 milligram nga dose of that drug, no problem with the effect. Okay? It carries, no, it elicits a particular effect or response already. but not that 50% is achieved, 50% from the maximal, from its maximal effect is achieved, but somehow it elicits an effect, okay? But it's not the maximal one. Now, para ma-achieve yung maximal efficacy for this drug, no, A, we could change the dose. We could add a dose. Pwedeng from 1 milligram, tingnan nyo, pagdating sa 2 milligram, na-attain niya yung agad-agad, no? Na-attain niya agad-agad yung maximal na response. So we can see here na kapag very steep, kasi ang slope dito, di ba? Ang slope dito is very steep. Okay? Steep, very steep yung slope being illustrated for this graph. Kapag steep pala yung slope being graphed or plotted, with just a very small adjustment of the dose, di ba? From 1, nag-add ka lang ng another 1 milligram, very drastic yung change sa response. Okay? Kapag very steep yung plotted graph. Diba? You start with a low nga dose, then nag-add lang ka og another dose, or nag-add pa ka og another pa gyud, kuan ka, dako kaayo ang extent sa change sa response. Dili siya slowly ba? Okay? So that's the kumbaga relationship for having this parameter slope. Okay? Pero kapag ang graph naman is not steep, like this, diba? Hindi man steep yung curve dito. Ano ba? 1 gram. So 1 gram concentration, okay, na meron siyang effect. Okay, meron siyang response elicited. And then let's say, adjust na naman. If ever the dose of the drug has been adjusted from 1, then gawin natin 2. Okay pa rin yung effect. No? Hindi ganun ka-drastic compare sa steep plotted nga graph. So ito, between the two, ang can be adjusted with no drastic nga kuan grabe nga degree of change sa response would be the not steep nga slope. Okay, so it can be adjusted. Okay? Sa steep 1, ang inyong ma-rationalize ani, dili ginusagad mag-add if steep ang plotted nga graph. Okay, meaning to say, probably narrow yung therapeutic line ng isang gamot. Kumbaga, by just adding or adjusting a very small dose of that drug, pwede siyang makakos ng very harmful or adverse na nga effect. Okay? Unlike the other drug na dili kaayo narrow yung therapeutic niya nga line or window, pwede nimo siya ma-adjust anytime. Okay, until such time nga dugay-dugay pa man pod no siya ma-attain nimo iyahang toxicity. Okay? So yan naman yung importance ng slope dito. Pero again, hindi man siya ma-apply later sa atoang application. More on diri gyud siya mo matunong ang mga applications later. But this one is also helpful for you to realize nga there are drugs nga if you try to adjust their dose, there could be really a drastic degree of change sa ilahang response. So kapag not steep, it's good, it can be adjusted. Kapag steep, careful good adjust, careful, very careful. Dapat you have to start low, then you have to go low then, no? Dili sagad. If it is a steep plotted graph, you have to go low, then start slow, then go slowly then. Okay? Sige. Now, yung graded dose response relationship, ang dami niyang applications. Okay? Pwede siyang gamitin to determine the potency, efficacy of the drug. Okay, so let's try this one first. Ayan. So how do we determine the efficacy and the potency of the drug given the graded dose response curve? Okay, so halimbawa, ito. You have three sets of drugs. You have drug A, drug B, and then drug C. So meron silang kumbaga plotted curve based on their dose and then response relationships. Again, sa x-axis is the dose of the drug, y-axis the effect of the drug or the response. You have three drugs here, A, B, C. Then you will be asked, halimbawa, among the three, which is more effective? So, kumbaga, you try to determine which is more effective, which is more potent here, which is least potent, which is least effective. So pwede nyo siyang ma-identify given this graph. Balikan natin yung efficacy. Di ba sabi sa efficacy, yan yung maximum achievable response of a drug. You start with drug A. What's the efficacy of drug A here? Diba? Example, this is 100 ha. Halimbawa, this is 100. Ito naman, yung 50. Ito, of course, 0. The basal. Okay? So, drug A has this point of efficacy na at mo ni iyahang point of efficacy based sa iyahang curve ha, based sa iyang curve. Same with drug C. Same with drug C. For drug B, its efficacy, maximum rather, yeah. Efficacy is the maximum ha, maximum achievable response. Yan naman yung drug B. So, i-label ko ha para hindi mawala. Again, ito yung efficacy. E for efficacy. Maximum achievable response of a drug. Ayan. Okay? Balikan yung potency. Sabi sa potency, yan yung dose naman para ma-achieve yung 50% ng maximum response. So ito, efficacy of drug A and also efficacy of drug C. Ito naman, itong nasa baba, efficacy naman yan of drug B. Okay? Now, if you will be asked what will be the order of efficacy from most effective to the least effective one? We could tell nga, pwede nating ma-rationalize dito na drug A is equally or have the same efficacy with drug C. And they have greater yung efficacy nila, greater yung efficacy nilang dalawa kay drug B. Base dito ha nga, plotted graph nila. Paano naman kapag you're asked what would be the order of potency? Sino dyan yung more potent? Okay? Okay. Sino naman ang least potent? O, tingnan ha. Okay, balikan yung potency. It should be 50%, dose required to attain 50% of the maximum response. Dose siya ha, yung potency is about the dose. Efficacy, it's about the response, so sa y-axis. So, let's start with drug A. Si drug A, ito daw yung efficacy niya. Tingnan. So, meaning, ang 50% sa 100, 50% sa 100 is 50. Okay? So, ibang kulay ha. So, ito yung magiging 50%. Tama? Ng 100. So, you have to plot that hanggang kay drug A. Ayan. Then, plot it down. Plot it down. Ito yung potency ni drug A. Okay, I hope you understand that. It's the concentration, it's the dose of the drug to achieve its 50% ng kanyang maximum response. Yung maximum response man niya is 100 daw dyan. Okay, let's have drug B. Ang drug B, from color blue muna for a while. Ayan. 'Di ba? From its maximum, ito yung efficacy man ni drug B. Iyang 50% would be, hypothetical lang ha, dili man kay ko straight yun maglantaw kung i-half. O man gyud line, wala man gyud siya line. So halimbawa, this is the 50% of the maximum response ng drug B. Kasi ito 'di ba yung maximum response ng drug B? Nadira nga point. I-half, kuhaon nimo yung half sa iyang maximum response, dira ka mo subay. Okay? For it to get its potency dose. Then arrow down. Meaning to say ito yung potency of drug B. Okay? Potency P tapos subscript B. Next. Ang drug C naman, drug C, ito ulit, yung potency, efficacy maximum, kunin 'di ba yung 50%. Ito yung drug C ha. So same sila 'di ba ng efficacy ni drug A. So kunin mo yung 50% ng kanyang maximum response, same sila ni drug A. So ipadayon lang ni, okay? And then this is for drug C, then plot it down. Ito yung potency ng drug C. Question, which is the most potent drug? A, B, C. Okay, very good. So in this given example, we could tell nga drug A is more potent than drug B. And the least potent drug is drug C. Okay? So I hope you understand. So you can really apply the graded dose response curve if you try to identify the efficacy, potency, if nakaplot in a graph yung kanilang dose response relationship. Okay, you really have to understand efficacy and potency na definition first before you apply it. You make use of its application. So ma-realize ninyo dire, look at, we could tell here nga tingnan, di ba, efficacious, more effective drug si C, but it is the least potent one among these three. So it doesn't mean that the drug that is potent, it is also the most efficacious. So it does not goes along no nga kapag more effective siya din ba yung more potent? Hindi po yan ha, applicable. Hindi yan directly proportional yung efficacy and potency. Pwede ang gamot more effective but it could be the least potent one. Pwede din naman na siya yung more effective, pwede din siya yung more potent. So may mga ganun na mga gamot. Okay, let's have another example. Okay, this one. Tatlong drugs ulit. A, B, at saka C. Okay? By just looking at the graph agad-agad, which has the same efficacy. Looking at the plotted graph. It's both, okay, A and B. Okay, both A and B. Both A and B, efficacy nila. Yan, A and also drug B. Okay? Then, least effective naman yung drug C. What about the most potent drug? More potent. Okay, that would be drug A. Okay, very good. Sige. So you can just read this for you to realize that there could be potent drug but not that effective. Okay? There are also least potent drug but they have higher efficacy. Okay? So, ayan. Sige. Another application of the graded dose response relationship is in identifying or comparing the efficacy or their response, not efficacy. Um, we could make use of this graph para compare, comparison ng responses of agonists, different types of agonists, may it be full, partial, or inverse agonist. Okay, di ba? I've mentioned earlier about the intrinsic activities of these three, di ba? They only differ on their intrinsic activity. Full agonist, it attains the maximal effect, meaning intrinsic activity niya is the full effect. Kaya, kung titingnan niyo sa graph, graded dose, response curve, yung kulay blue daw. Kulay blue, tingnan sa graph, it attains the maximal effect. That's the full agonist. Ano sabi natin sa partial agonist? Intrinsic activity niya is greater than, greater than 0 but less than, no? Greater than 0 but less than 1. Okay? So yan yung intrinsic activity naman ng partial agonist. Kaya, kung titingnan mo sa graph, yung kulay pula, this is for inverse agonist. So let me label na lang. This is full agonist. This is the partial agonist. It's in between 100 and above 0. That's partial. Okay? So it's above 0 but less than the maximal effect. That's partial agonist. Then the inverse agonist, itong kulay green. Kaya sabi natin kanina, inverse agonist, negative yung intrinsic activity niya. Kaya tingnan yung curve, plotted graph, baba ng 0, negative yung activity niya. Okay? Question, ano kaya yung nasa 0? Anong klaseng ligand? Okay, very good. Probably dito, antagonist, a neutral antagonist in particular. Okay. Next, another application of graded dose response relationship. Regarding competitive antagonism, okay, in studying for the presence of competitive or non-competitive antagonism, we can also make use of this curve. Diba? Ang concept natin kapag competitive antagonism, we can overcome the effect of the antagonist by simply increasing the dose of the agonist, increasing the concentration of the agonist. Okay. Tingnan nyo sa graph. You can see here na you have an agonist alone. Ito yung graph niya, plotted curve. Again, this is agonist alone. But when you check the other plotted curve, it moves to the right. It shifted to the right. Okay? Tingnan, when the agonist is combined with antagonist. Okay? When it is combined with antagonist, it shifted to the right. Meaning, sa nag-shift to the right, what happens to the dose? What happens to the dose of the drug if it shifted to the right? Increase or decrease? Okay, nag-increase. And that's the purpose, di ba? If competitive antagonism, we have to increase the dose of the agonist. Why? Para ma-overcome yung effect ng antagonist. And look at the efficacy. Upon increasing the dose of the agonist with the antagonist, when it is combined with the antagonist, it surmounted the effect of the antagonist. Kaya it still attain the response for the agonist. It still attains the agonistic response. Okay? Mapa-alone or with agonist. As long as you increase the concentration of the agonist, we can surmount or um, completely overcome the effect of the antagonist. That's why ganito yung nangyari sa graph. Shifted to the right, and then what happens to the efficacy? Same efficacy. Okay? Sige, next. Non-competitive this time if upon increasing the dose of the agonist, it will not surmount, okay, or it will not completely overcome the effect of the surmount, SU, okay, effect of the antagonist. So non-surmountable kahit nag-shift to the right yung graph, uh, graph ng agonist with the antagonist. O tingnan. This is the plotted graph of the agonist alone. So it has this efficacy. For agonist alone. Okay? Now, with the presence of an antagonist, particularly, di ba, this is an allosteric antagonist, or sabi dito, it is an irreversible antagonist. So may kasama siyang irreversible antagonist. So let's try to increase the agonist. Tingnan, kaya medyo nag-shift, di ba? May shifting to the right. But look at the efficacy. Even though you increase the dose of the agonist, you cannot surmount anymore the effect of the antagonist. You cannot completely overcome anymore the effect of the antagonist. So that's the graphical representation naman if it is non-competitive. It shifted to the right, but the efficacy, okay, of the agonist with the antagonist is lesser than the maximal response, okay, ng initial agonist's response. Okay? So ito yung magiging itsura ng isang non-competitive antagonism. So there are questions no sa exam na pwede kayo ipa-identify kung anong klaseng antagonist being illustrated in that graph. Okay? So you just understand or familiarize yourself on the usual representation if it is a competitive antagonism or a non-competitive antagonism. Same thing with the partial, full, and the inverse agonist kanina. Okay? Sige. Next, this will be the last topic or last type of curve. Under dose response relationship. Okay, let's proceed with quantal dose response relationship. Okay, this particularly describes the distribution of the minimum dose of a drug required to produce a defined degree of a specific response in a population. So this time the baseline is within population. Yung kanina graded dose more on focusing on individuals outcome nila on that drugs concentration given to them. Ito naman yung magiging outcome occurrence ng population, ng isang population being the subject, kung ano yung na-elicit nila na general response given that drugs dose. Okay? So again, sa quantal dose response relationship, we are focusing here more on the population dynamics. Okay, or sometimes in other references, ang quantal dose effect or dose response relationship is also known as all or none. All or none dose effect relationship. Okay? Or curve. Sige. Okay? So yung makikita natin sa plot ng isang quantal dose response relationship, instead of absolute numbers of degree of responses, katulad kanina for the y-axis, di ba sa y-axis kanina is more on responses, yung nasa y-axis. This time, yung nasa y-axis of the graph for quantal dose response curve is more on the cumulative number of patients, okay, or cumulative number of population, okay, patients, okay. So percentage of the patients, percentage of the individuals sa population showing an effect yung nasa y-axis. Okay? And then on the x-axis, ganun din, dose pa rin ng gamot. Okay? So yan yung nasa y-axis and then on the x-axis. Okay? So ulitin ko ha. Sa quantal dose, y-axis, it plots the cumulative number of patients. And then on the x-axis, it's the drug dose. Again, ang focus dito, outcome occurrence being observed sa general population, which is given with a certain dose of a drug. And of course, di ba, iba-iba man yan yung magiging general outcome occurrence nila. May mga taon na, they elicit therapeutic effect. Okay? There are also those na pwedeng ang effect or outcome occurrence of the population is a toxic effect. Ayan. Okay? So again, pwedeng a therapeutic effect or upon increasing the dose, it could bring about adverse effects sa general population. Okay? Now, before we make use of the application of quantal dose response relationship, ganun din, let's talk about the parameters involved in a quantal dose response relationship. Number one is the ED50. ED50 is also considered the median effective dose. It's the median effective dose. Okay? Ayan. So yung median effective dose, that is the effective dose in 50% of the given population. I repeat, that's the effective dose in 50% of the given population. Okay? So, sulat ko muna ha. Halimbawa, yung unang plotted graph dyan tells us about the therapeutic effect of that drug. And of course, if we increase more of that dose of a drug, that's the time adverse effects of the drug are being observed in a general population. Okay? So kapag sinabing effective dose, yung magiging baseline mo is the plotted graph under therapeutic effect. Okay? 50% man daw of the population. So yung magiging if median effective dose, so from 50% of this population, you start plotting it to the curve ng therapeutic effect, then plot it down, then this would be the effective dose in 50% of the population. So that's the median effective dose or ED50. Ang TD50 naman, this is the median toxic dose. Median toxic dose. Okay? So ito naman has something to do with the toxic effect ng gamot. So it's the toxic dose. Toxic dose in 50% of the given population. So somehow you know already how to identify what could be the TD50 of this given plotted graph. So kapag TD50 from toxic dose man daw sa 50%, so this will be your baseline, yung curve for the toxic effect, and then plot it down. This would be the TD50. Again, that's the median toxic dose or the toxic dose in 50% of the given population. Okay? So you have here the beneficial effect. Ito naman, the toxicity or toxic effect. Okay? Ayan. It's easy to understand these parameters if you apply this on the graph. Okay? And then kapag naman therapeutic index, it tells us about the safety of the drug. It measures the relative safety of the drug. It measures the relative safety of the drug. Okay? And we have a formula to determine for the therapeutic index of that drug. So in order to determine the therapeutic index, which is usually designated with capital I, therapeutic index, it's TD50 over ED50. Okay, it's the ratio of the dose that produces toxicity to that of the dose that produces um, the desired response. Okay, or the effective response or therapeutic response. Okay? So kung titingnan sa graph na to, illustrated, yung magiging therapeutic index is itong window na ito in between the therapeutic effect or TD50 and also ED50. Okay? So yung window sa graph na yan or the therapeutic window dyan, yan yung measure of its safety ng gamot. Okay? And we could tell na kapag yung window na yan is kumbaga malaki siya, malaki yung ano yung opposite ng narrow? Broad. Okay. Kapag basta malaki yung window dyan, we could tell na safer yung drug. Pero kapag very narrow, magkalapit yung kumbaga space dyan in between the TD50 at saka ED50, we could tell nga merong narrow therapeutic index yung gamot. And we have different examples of drug na merong very narrow therapeutic index, and they need to be monitored if given to the patient kasi konting changes lang sa dose ng gamot pwedeng makakos ng harmful adverse effect to that patient. Okay? Examples ng mga narrow therapeutic example ng drugs na merong narrow therapeutic index are the following. You're familiar with digoxin. I know you have heard about digoxin. Another example is yung warfarin. Ayan. Meron yan silang mga narrow therapeutic index. Another example is theophylline. Okay? Ayan. So halimbawa lang po yan ha ng mga gamot na very narrow yung therapeutic index, and careful talaga yung pag-monitor ng mga gamot na yan if they are being prescribed or given, administered sa pasyente. Okay? Sige. Let's try to apply this. Ito lang din yun. Yung ginawa ko kanina na illustration. So you already understand how to identify the ED50, the TD50. Let's say, for instance, in this given graph, let's say you have here the therapeutic effect of a certain drug, and let's say therapeutic effect. Ito ha, therapeutic effect. And kapag sinabing therapeutic effect, yun yung mga desirable responses na dapat elicited by a drug. Let's say, pwedeng ang drug na yan, halimbawa lang, anti-allergy yung gamot. So let's say, it could subside the allergy. Then let's say, in increase yung dose of that drug. So that's the time. Okay, beneficial ito ha. That's the time elicited na yung mga adverse effects. So toxic effect naman ito. Okay, so halimbawa lang, hypothetical, nausea and vomiting. Okay, then you are asked in this given na plotted graph for quantal dose response relationship to identify for the or determine for the ED50 and the TD50. Median effective dose to median toxic dose. Okay, so from this cumulative number of patients, look for the 50% of that population and then graph it for each na kumbaga observable outcome occurrence, pwedeng therapeutic effect or toxic effect. So ito, under toxic effect, the effective dose na observed sa 50% of the given population, that's that ED50, so that's 10 milligram. Okay? Milligram to halimbawa. Okay, so ito yung magiging ED50. Whereas, the TD50 would be, ayan, so dito 25. Okay? 25 naman yung TD50. Okay? Then you are asked, halimbawa lang, for the therapeutic index. No? Therapeutic index, kung ano yung measure that relates to the safety of the drug. Okay, very good. You simply get the ratio of the TD50 and ED50. So, sulat ko muna ha. It's TD50 over ED50. So, you simply substitute. It's 25 milligram divided by 10 milligram. So, may yung magiging index. No, index would be 2.5. Okay, so kumbaga yan yung measure of pwede mong ma-adjust yung gamot. Okay? Kasi more than that, ma-attain mo na yung adverse effect of that drug. So that's the therapeutic index 2.5. Lesser or lower na mga therapeutic index would tell us na meron siyang very narrow therapeutic index and hindi safe ganun na ibigay yung gamot na basta-basta lang siyang i-prescribe. It should be highly monitored if in case very narrow yung therapeutic index ng isang gamot. Kasi konting kibot lang dyan, harmful na agad na siya adverse effect. Okay? Sige. So I think that's the last slide. Okay. Do you have any question?
None, ma'am.
Okay, since you have no questions, I will now dismiss the class. Sige, thank you for listening. I'll see you next meeting. Sige, thank you.
Thank you, ma'am.
Yes. Yes, yes. Oh, yes. Saan si Sabio?
Regarding sa katong therapeutic index ma'am ba, naay ka ng specific nga range sa calculated nga therapeutic index ma'am nga may bala na to if kanang isa ka drug is already kanang narrow na ba siya nga therapeutic index or kay ingon ka ganina mga the lesser the therapeutic index the more narrow siya na ba tay
Kung
range na gina follow or indication.
ang imuhang pasabot if naabay ka ng specific nga example 1 to
Yes
0
ma'am
to
yun
1
na.
ana. Okay. Wala gid siya specific nga kanang number or value man yata yung ipangutan value kung kana nga specified. Basta kay kung large kaayo siya like 5, 6 may nga na, I think kung ano gina siya kanang we consider nga dili na gid safe ang drug having that larger value sa therapeutic index. Wala so far. Kung wala siya kanang range wala, I think. Oo, wala siya range na akong kuan. Basta kay very low 0.5, kung very I no, baliktad ang akong ingon. Basta large yung therapeutic index, safe ang usa ka drug. Yun ba yung sinabi ko kanina?
Yes ma'am, the broader the safer.
Oo. Kung broader yung window, yung therapeutic window, the safer. Kasi malayo pa hanggang ma-reach yung toxic. Oo. Pero kung kuan, kung bitaw no, it makes sense kung naabay value or range. Wala ko'y makuan nga range gyud, but the rationale is talagang the lower it's kung nice set of drugs na binigay sa inyo and then given yung therapeutic index nila na ang isa 2.5, then yung isa 5, then yung isa let's say 4, then pina-identify kayo which do you think is a more safer drug given their therapeutic index, then just know nga the one with the lower therapeutic index value, that drug is really not safe drug. Kaya kailangan i-monitor yun ang usa ka pasyente if that drug is being prescribed having or knowing na very narrow ang iyahang therapeutic window or therapeutic index. Ana lang siguro ang inyong pag-rationalize.
Okay ma'am, thank you po.
Yeah, pero pag larger naman, so no problem. Taas-taas pa, pwede pa magdugang. Oo. Sige. Thank you for that question, Mr. Sabio.
Thank you ma'am. God bless
Sige,
po.
sige.
Bye-bye.
Bye-bye. Thank you.
Bye, ma'am. Thank you, ma'am.
Okay, sige, sige. Thank you.